from a production standpoint, that those animals make less milk in the next lactation. And that's what I'm presenting here. Right? These are data from one of our studies showing the effect of late gestation heat stress on productivity in those animals in the next lactation. The open symbols were exposed to heat stress for their dry period, and the animals in the solid symbols were cooled and actively cooled for that entire time. And this is in dry cows. What we're seeing here is the elevation in temperature in the morning in one study that we did, and we see a significant elevation in the afternoon. Typically, we're talking about 0.4 to 0.5 of a degree Celsius increase in temperature in those animals, which on the surface may not seem like a lot. It's certainly not a febrile response that you'd see, with a fever in animals under some kind of other pathology. But when you think about how we do these experiments, we essentially dry animals off, and we're targeting about a 47, 48-day dry period. So we dry them off, they go into this heat stress, and they don't have a normal body temperature until they calve in that sort of 6, 7 weeks later. So it's almost like having a continuous low-grade fever for that extended period of time. These are all of the published studies that are out there. Many of them are ours, but other labs have done this as well. They all show the same thing, right? She's cooled, she makes more milk in the next lactation versus her herd mates that are heat stressed in late gestation. So we actually looked at this in one of our earlier studies to assess the impact on epithelial cell proliferation and loss during the dry period under heat stress, and also as those animals moved into lactation. So what's presented here is an indicator of cell proliferation. Okay, and this was done about halfway through the dry period. This is about 3 weeks before those animals calved in. And we can see pretty clearly that the rate of proliferation is increased in the epithelial fraction of the mammary gland, right? That's on the left side. The middle side is stroma. Those are the connective tissue, the blood vessels, the other sort of supportive tissues within that mammary gland. And that pattern is the same. And so if you look at the total proliferation of mammary cells, it's increased in the animals that are cooled when they're dry over the animals that are heat stressed. So that's pretty strong evidence that there's a potential for increased capacity for milk yield in that next lactation if an animal is cooled. What we did was just take records from cows that were dry during the hottest time of the year, June, July, August, and compared it to a genetically similar group of animals that were dry during the coolest months of the year, December, January, and February. And then just looked at productivity in those animals, but also disease incidence in those groups of animals. And so first thing, that top line is milk production. You see that the animals that were dry during the cooler months actually produced about 2 liters a day more than the animals that were dry during the hottest months of the year. We have not seen much at all through multiple studies, and we'll see the one-off changes at times, but we haven't really seen any effect on milk composition, either fat or protein. We just set up our normal model. That's in panel A and B. Cows were dried off into our cooling or heat stress treatment. Got an increase in rectal temperature in the heat stress cows, got an increase in respiration rate. Nothing too surprising there. About halfway through the dry period then, we took the animal, half of each of those groups, and shifted them to the other treatment. So for the entire study, we ended up with 4 groups: cows that were cooled the entire time, cows that were heat stressed the entire time, cows that went from cooling early in the dry period to heat stress later in the dry period, and cows that went from heat stress early in the dry period to cooling later on, which would be, like cooling animals just during the close-up phase. And if we look at the responses in those animals from a temperature standpoint and a respiration rate, they did just exactly what we expected them to do.